Okay, recording is started. So, good morning, students. This is a class of geotechnical engineering. So, we are discussing uh, about permeability of soil, which is under module 2. Okay, and till last class, we have discussed about what is permeability of soil, what is Darcy's law of flow of water through soil, seepage velocity, discharge velocity, then falling head test, and constant head test for determination of coefficient of permeability and factors affecting permeability. So these all topics are already covered in the last previous classes. So today we'll discuss about permeability of stratified soil deposit. So in the last class, during the discussion of factors affecting permeability, uh, I have mentioned one factors, that is the permeability is not same, or permeability may different depending on the flow water in case of stratified soil deposit. We already discussed about stratified soil. So what is stratified soil? It is kind of a layered soil where each layer have individual soil property and which is different from other layer. Okay, that's why it's called layered soil or stratified soil. So we already discussed that the uh, permeability of flow of water through soil parallel to the stratification may be different from the permeability of soil perpendicular to the stratification. So we are going to discuss about uh, the equation of determination of coefficient of permeability in case of stratified soil when the flow is parallel to the bedding plane. It is a case 1, and case 2 when the flow is perpendicular to the bedding plane or stratification. Okay, regarding stratification or bedding plane, I think it is already discussed in soil mechanics. Also in I think in geology also you have got this bedding plane, isn't it? Okay, so first let me share my screen. So I believe the screen is visible to you. So today also I have uh, I will going to present one screenshot which is taken from the book of soil mechanics written by B.C. Punmia. Okay, so we are going to discuss about permeability of stratified soil deposit. Okay, so here it is a it is an introduction part. It is mentioned here. What is mentioned here? In nature, that means in actual practice, in nature, soil mass may consist of several layers. Okay, a second. Yeah. So in nature, soil mass may consist of several layers deposited one above the other. Their bedding planes may be horizontal, inclined, or vertical. So these things, I think you will get this in geology. Each layer of stratified soil assumed to be homogeneous and isotropic and has its own value of coefficient of permeability. Okay. The average permeability of the whole deposit will depend upon the direction of flow. The average permeability of the whole deposit will depend upon the direction of flow with relation with the direction of the bedding plane. Okay, so we can define or we can find out the value of coefficient of permeability for a stratified soil or a stratified soil deposit, okay, and it depends on the coefficient of permeability depends on the flow direction, whether the flow direction is parallel to the bedding plane or perpendicular to the bedding plane. So in that note, we can define coefficient of permeability for stratified soil under two cases. That is, first case is your the flow is parallel to the bedding plane, and case two, the flow is perpendicular to the bedding plane. Okay. So here you can see two cases are derived very clearly here. Okay. So this is also this picture is taken from Soil Mechanics and Foundations uh, from BC Punmia. Okay. Author name is BC Punmia. So page number 96, 196 may be here. So you can also find out this one. Or if you can need, I can also send this in your WhatsApp group. Fine. So let's discuss first about the average permeability of soil when the flow is parallel to the bedding plane. Okay. So to understand this phenomena, you can imagine this line diagram. Okay, you can understand this from line diagram. So in this line diagram, here you can see this stratified soil. This stratified soil is fitted between two overhead tank. So this stratified soil having how many layer right now? N numbers of layer. Okay. So suppose this is the layer number 1, layer number 2, layer number 3, like that similarly up to layer number n. Okay, it's any arbitrary number. Okay. Suppose n numbers of layers are exist here, which is together they are known as stratified soil, and each layer have own property. Okay, say Z1 is the thickness of the layer 1, Z2 is the thickness of layer 2, Z3 is the thickness of the layer 3, and like that go on. Fine. And here from in the left side, it is fitted with an overhead tank, and which is little bit higher, which is at a higher elevation uh, from this uh, the tank which is fitted in the right side. Okay, so here you can see the head difference is how much? H. Head difference matlab the small h represents what? The difference in the head. Okay, due to which water flow from higher elevation to lower elevation, or you can say higher gradient to lower gradient. So obviously the water will flow in this direction since this is in a higher elevation. Okay, so if you pour some water in this overhead tank, and if you allow water to pass through this soil, pass through the certified soil, the water will, which is the discharge is represented by Q. Okay, say small q, it represents discharge or rate of flow, or the amount of water flowing per unit time. Okay, this small q amount of water flowing through this soil mass within a particular time. Okay, and it is come out from the left side, it will go like this since water is flowing in this direction. So in this process, what is the value of coefficient of permeability? Okay, you can derive from this equation. Okay, so here you can see the bedding plane is in this direction and flow is also in the same direction. So we can say the flow water is parallel to the bedding plane. Okay, and the velocity at the instant of the entry, it is v, small v, you can say the small v is what? It is the velocity of water or flowing water. Okay, now here you can see it is written here, let z1 z2 zn are what? The thickness of layers. Okay, these z1 z2 z3 are the thickness of the layer, and k1 k2 and k3 up to kn are what? Are permeabilities of the layers. So say k1 k2 k3 are the individual coefficient of permeability of layers 1 2 3 and so on. Okay, we need to find out the average permeability of the stratified soil. We need to find out average permeability, and since the flow is parallel to direction, suppose this direction we consider as x direction, so we can find out or we can denote the average permeability by Kx. So here you can see, let Kx is the average permeability of the soil deposit parallel to the bedding plane. So x represents the direction, this horizontal direction represented by x. Okay, it's just a symbol. Now here some concepts are there, or you can say some theory, or you can say theorem. For flow to be parallel to the bedding plane, the hydraulic gradient, that is I, will be same for all the layers. Okay, that means since H will not going to change throughout the flow of water across this soil layer, this H will not change, and the length traveled by this water, that is which length? This length, the length of this soil. Suppose L is the length of the soil, which is similar for each layer. Okay, since H is constant, L is constant, that means we can say hydraulic gradient, which is represented by H by L. Hydraulic head divided by length traveled by the water, H by L. Hydraulic gradient also remain constant when the flow is parallel to the bedding plane. It is a very important term you have to remember in case of the uh, flow parallel to bedding plane. Okay? So here you can see, when for flow to be parallel to the bedding plane, the hydraulic gradient I will be same for all the layers. However, the velocity v, that is discharge velocity, or you can say Darcian velocity, v is equal to ki, and since k is different, the velocity of flow will be different in different layers. Now, since this is a stratified soil, okay, and each layer have its own property, so k1, k2, k3, and up to kn all are different value. So since k may be different for each layer, so velocity of flow through each layer also be different. Why? Because k is different for each layer. Although I is same for all layers, since k is different for each layer, so velocity of flow through each layer will also be different, isn't it? So water is flowing in this direction, and it will passes through each layer like this. Okay, and with different velocity. So velocity of flow will be different in each layer in case of flow parallel to bedding plane. This is another important term. Okay. Now let Kx is the average permeability of soil deposit parallel to a bedding plane. It is already discussed. Okay. Now we can say that total discharge through the soil deposit, which must be equal to sum of discharge through individual layer. Now, since Q amount of water is flowing through this uh, system, and this Q is distributed through this layer, okay, so we can say the total summation of the discharge through individual layer must be equal to Q, isn't it? So it's a very simple mathematics, fine. And each layer, the value of Q also be different. Since velocity is different, the discharge through each layer also be different. So you can see Q1, Q2, Q3 up to Qn are what? They are the discharge or rate of discharge per unit time through each layer, fine. So by mathematically we can say the total discharge or total discharge through the soil deposit must be equal to Q1 plus Q2 plus Q3 up to Qn. Fine. So since we know as per Darcy's law, Q is equal to KIA, isn't it? We know Q is equal to KIA. So in this case, especially in this case, since this is a line diagram, taking the thickness of this diagram as 1 unit, we can consider the cross-sectional area as Z into 1 or simply Z. Okay, so this Z is the thickness of the each layer, and the uh, other side here you cannot see, it is perpendicular to the drawing. This direction, this represents, we consider as a 1 unit. Okay, since it is a two-dimensional, consider this is a two-dimensional diagram. Okay, so in place of cross-sectional area, we can consider simply the thickness of the layer. So we can say, or you can derive, the total discharge, which is Q, can be represented by KIA or KIZ. Now K can be replaced by Kx. Okay, Kx what? Your average permeability. I is your hydraulic gradient. Z is your what? Z is your total thickness of the layer. It is capital Z. It is a total thickness of the layer. Where Z is what? Capital Z is equal to, you can see, Z1 plus Z2 up to Zn. That means summation of its thickness. Total thickness of the layer is of what? Z. Here you can see. Okay. Now, same way we can find out Q1. Discharge through the layer 1. Q1 by using the same equation, that is Kia or Kiz. In place of K we can write K1. I will be same since hydraulic gradient is constant throughout the same layer, and in case of Z we can put Z1. This is for first layer, similar this is for second layer, and so on. Okay, so by simplifying this relation we can derive the equation for coefficient of permeability when the flow is parallel to the bedding plane. And the equation is, here you can see, Kx is equal to K1Z1 plus K2Z2 plus K3Z3 up to KnZn divided by total thickness of the layer. You have to remember, okay? In some many exam question may ask about this formula, where Z is where Z1 plus Z2 up to Zn. Okay, same case, let's discuss about this second case. If you can understand this case, it is very easy. It is also easy to understand the second case also. So in the second case, we need to find out the coefficient of permeability or average permeability when the flow is perpendicular to the bedding plane. Now, can you see the difference between these two drawings? In this, the first case, the flow is parallel to the bedding plane. Okay, now here the flow is perpendicular to the bedding plane. Now flow is going from bottom to top. Since the head difference is h, okay, like this. Okay, it is clear. I think from the drawing also you can understand which drawing is for parallel to the bedding plane and which drawing is for perpendicular to the bedding plane. Okay. 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 So in the second case, the velocity of flow and the velocity of flow is going to be constant throughout the its layer since the flow is perpendicular to the bedding plane. So you have to remember that when the flow is perpendicular to the bedding plane, the velocity flow will going to remain constant. So you can see v is represent, okay. In the first case, it is represented by v1, v2, v3 since velocity flow is not constant when the flow is parallel to the bedding plane. But when the flow is perpendicular to the bedding plane, you have to remember that the velocity of flow is constant. That's why only v is represented the velocity of flow. And since the velocity of flow is constant, hence the unit discharge or rate of discharge is also going to be constant. So the Q, the discharge through each layer, is also going to be constant, because in this case here you can see the difference. At the same time or at t equal to 0, the Q is distributed through each layer at the very beginning of time, say t equal to 0. But here at t equal to 0, that means at the instant of the layer, this amount of discharge, suppose Q amount of discharge is first enter the layer 1, then it's enter the layer 2, then layer 3, then up to go on like that. Okay, so since in this case, that's why the discharge, the Q discharge remain constant through each layer. Okay, so here you can see representation of the layer. This is layer 1, 2, 3, and so on up to layer Kn, a layer n. And the K1, K2, K3 up to Kn are what? They are the coefficient of permeability of each layer. Okay, and Z1, Z2, Z3 up to Zn are the thickness of the each layer. Okay, so velocity will going to remain constant throughout each layer, and unit discharge, that is value of Q, also going to be constant through each layer. So in this case, velocity of flow, hence the unit discharge will be same through each layer. However, hydraulic gradient and hence the head loss through each layer will be different. Okay, Since these layers are one above another and the flow is in this direction, the hydraulic gradient or and the hydraulic head is not going to constant for its layer. Okay, it's going to be vary. Finally, it will reach the value total hydraulic difference is h, but for individual layer it is not uh, equal to total h. Okay, h is the summation of h is what? H is your total head difference because of which the water flowing through this flowing through this soil. But h is the summation of the individual head difference for the flow of water through soil 1, soil 2, soil 3 like that. So we can consider uh, the head loss for each layer. Okay, so say denoting the head loss through the layers by H1, H2 up to Hn and total head loss as H. We can write the total head loss H equal to H1 plus H2 plus H3 up to Hn. That means H is represented by that is represent the total head difference and it is the summation of the head difference in the individual soil layer where H1 is the head difference for layer 1, H2 is the head difference for layer 2 and so on. Okay, now we can derive the value of H. H can be represented by I Z1. How can we write out? By the formula of hydraulic gradient. Hydraulic gradient is represented by what? H by L, isn't it? H by L matlab what? Hydraulic head divided by the length traveled by the water. Now, if I consider the layer 1, the water is flowing in this direction. So the length traveled by the water through this layer 1 is what? Z1, isn't it? So in place of L, we can write Z1. And H1 is what? Hydraulic head for this layer 1. So H1 by, excellent. So H1 by Z1 represented by hydraulic gradient I1 for layer 1. So indirectly we can write H1 equal to I1 into Z1. Similarly, H2 equal to I2 equal to Z2. Okay, and so on. Okay, so we can write in this equation H equal to H1 plus H2 up to Hn. We can write H in the place of H1 we can write I1 Z1, in the place of H2 we can write I2 Z2 and so on. Okay, so you can write the equation number 1. So consider KZ average permeability perpendicular to the bedding plane. Now in this direction, suppose this direction represented by Z. So the coefficient of permeability in this direction is represented by Kz. Okay, fine. So we can write since V, that is velocity of flow of water through its layer, is constant, and as per Darcy's law, we can write V is equal to what? K into I. V is equal to Ki, isn't it? So we can write the V can be written as Kz into I, where I is a hydraulic gradient and Kz is your average permeability. Okay, and in place of I, we can write H by Z. H is your what? Total head. Z is the total thickness of the layer. Okay, and it is act as a the length traveled by this water. Okay, so indirectly we can write H equal to Kz into Z. Okay, H equal to, how can you write out? Oh, sorry, V into, we can write H equal to V into Z divided by Kz. Here you can see it's very important. Okay, H equal to V, that is velocity of flow, into Z, the length traveled by the water in perpendicular direction, or the thickness of the soil layer, divided by Kz. Kz is your average permeability perpendicular to the bedding plane. Also, we can write I1, I2, and I3 value of hydraulic gradient for through each layer. So I1, which is the hydraulic gradient for layer 1, can be represented by V is equal, since V is equal to Ki, so I can be written as I is equal to V by K. So V is constant for each layer, but for layer 1, K represented by K1. For layer 2, K represented by K2. For layer N, K represented by Kn. So we can write I1 equal to V by K1, I2 is equal to V by K2, In is equal to V by Kn. ठीक है? So substituting this all this value in equation 1. So in this equation, if you write all these things in place of h, you can write bz into kz, bz divided by kz. Okay. So in place of I1, you can write v by k1. Okay, and multiply by k1 z1. Just write all this value in this equation. Value means value of I1 and value of h. And simplifying this, you can find out this relation. That is v into z by kz equal to this equation. And simplifying this relation, you can find out the value of kz, that is coefficient of permeability perpendicular to the bending plane. That is kz equal to z divided by z1 plus k1 plus z2 by k2 plus so on, where z is your total thickness of the layer. Okay, so you have to remember this formula. This formula for average permeability for stratified soil when the flow is parallel to the bedding plane, and this formula is for coefficient of permeability for the stratified soil when the flow is perpendicular to the bedding plane. So next class we are also going to solve some problem also related to these two formula. Okay, so yeah, this is all about today class. I'm just going to close my sharing now. Okay. Okay, I think it is clear, right? It is not that tough to understand. If you still have some any doubt, you can also ask me now or even after the class also. Okay, so don't worry about that. Try to uh, try to go through that books or the notes. If you don't, even if you can't understand, you can also come back to me. Don't worry. So I'll just take the attendance now. Okay. So let me first close my recording. Stop my recording.